My name is Tiffany Walsh and I'm a Professor of Chemistry from the University of New South Wales in Sydney, and I'm visiting CSIC this week. I work with Dr. Cristina Pozo-Gonzalo, and together we investigate how to better recover and recycle precious metals that you can find in batteries and in the very powerful magnets that power our electric cars and wind turbines. And we need to be able to recover these metals that go inside these batteries and these magnets, because mining them isn't very easy. And sometimes the mines for these precious metals are located in places that might be very difficult for us to work with right now or in the future. So to be able to have a secure supply chain of these metals, we need to be able to find ways to take our old batteries and our old magnets and to be able to recover and reclaim those metals again. We do this using a process called electrodeposition. To be able to recover these precious metals, we use very special liquids. These are known as ionic liquids. These have great properties that enable us to be able to make sure that we can deposit these metals onto surfaces, and these deposits are very pure. This is not an easy task, and we need to be able to adjust the composition of these very complex liquids to be able to make sure that we can get a very pure deposit. So for example, we work with two metals that are very precious and current right now. One of them is cobalt, and you'll find this in many of your lithium-ion batteries, for example, in your phone or in your car, if you have an electric vehicle. The second is a metal called neodimio, and I know it sounds like a long name, but this metal is very important for those very strong magnets that are used to power our electric vehicles, and very important for driving our wind turbines and creating energy. Christina and I are working on ways in which we can adjust the composition of these very special liquids to make sure that we can get very clean deposits of these precious metals, of the cobalt and of the neodymium. The kind of research we do is very complementary. So Christina does all of the experiments, and we actually use computers to predict the structures of these liquids at, for example, an electrode interface, which is where the deposition happens. So we're able to predict what happens when you put these very complex liquids in contact with a flat surface. And then we can tell Christina, well, if you adjusted the composition of your liquid and maybe added a little more water or a little more salt or a little more of this molecule, for example, something like ethylene glycol, then you are able to get a better deposit. And we have been working with Christina to make sure that these processes can become as efficient as possible and as economical as possible, so that the process of recovering these metals costs less, is faster, and is more environmentally friendly.